As mentioned in the previous video, the big difference between spiking or pulsing neurons and the earlier ones that we discussed is that we need to take time into account with these newer pulsing types because their output varies with time. Or to put it another way, the neurons need to have a clock. This is because a pulsing neuron's output doesn't just depend on its current inputs, but also on where it is in its cycle of activity. The diagram on the screen now illustrates this for a pulse frequency modulated unit. In this case, the neuron's activity means that it is re-triggering every 6th clock pulse. So obviously we need some way of keeping count of what's happening. There are actually many ways of doing this, but probably the easiest way is to use a main or universal loop as a single universal clock tick, as shown in the diagram. So each time the program goes through the main loop, time advances one division, or tick if you like, on the output graph. At the beginning of this main loop, we evaluate the activity of all the neurons in the network using something like the leaky integrator technique, which we discussed in the last video. Having done this, we now run through each neuron in turn in the network once and update its state. Each neuron has its own local clock, which keeps track of where it is within its own individual cycle. The local clock allows us to keep track of each neuron's progress through its cycle and is itself reset once the cycle is over. We'll look at a particular case of pulse width modulated neurons as an example in a later video. Shown on the screen now is a printed summary of what we've just explored. Although the activation function, the leaky integrator, isn't explicitly shown on the screen, it would be at the start of the main loop.